Hello everyone. Today we're going to be talking about some of the main security concerns regarding Starknet. We're developing a smart contract on Starknet. The chain works a little different from Ethereum because of all the ZK stuff behind the scenes, and it generates a couple of different concerns that you have to be aware of. Especially finite fields, so essentially all data in the chain is represented by finite fields. I'll explain those in a short moment, but it's a different math logic behind the operations that can cause a lot of bugs. Another thing that's important is cross-chain calls. Essentially, you can pass messages from the layer 2, so from Starknet to Ethereum and vice versa, but that has a lot of security concerns too that you have to be aware of. And at last, there are some classic vulnerabilities from Ethereum that are very present in Starknet as well that you should be aware. The first point is finite fields. Essentially, this is a very important concept for those of us that like cryptography and more of the deep stuff in the mathematics of it. Essentially, for the normal developer, what you have to understand is what a finite field is. When you're working with cryptography and zero knowledge, we don't use normal numbers. We use modular numbers. This is a different branch of mathematics that has a lot of different implications on a lot of things. I will explain it very shortly, and if you want more information on top of it, I'll link some different videos and different tutorials in the description so that you can research further and get some more knowledge. But essentially, inside of Starknet, there's a number. We're going to call it P. This is not P, but it's a very large number that is chosen by the network to be the P value for the program. This P value, what it means is any variable that you use inside of your code must be greater than minus P/2 and smaller than P/2. What this means is there's a finite range in which numbers can be. And whenever a number overflows this, it goes back to the other side of the equation. So if it is P/2 plus 1, it's actually going to get converted to minus P/2 plus 1. So numbers go like that, and this can cause some bugs, some very unexpected bugs. It is like an overflow operation in a normal number, but it has some different implications because in Cairo, every single variable is a finite field. Because of the way the prover works, because of the way ZK works, it has to be this way. And what this means is anytime a user inputs any data into the contract for processing, they can actually input a number that is greater than the maximum values of the variable, which causes overflow or underflow. And this must be handled by the contract. If the contract does not handle it in a single point, it is possible to inject malicious values that are going to mess up the logic and cause negative balances, unintended transfers, and other mistakes. So it's very important to keep this in mind. I strongly suggest that at least the tech lead into the teams developing Cairo contracts gets a deep knowledge on cryptography and finite fields to understand what's going on behind this. It is very simple and once you understand it, but it can be a source of a lot of bugs. So it's very important to understand it inside of Starknet. Given that Starknet is a layer 2 solution to Ethereum, a scaling solution using ZK rollups to scale it, Starknet is actually a contract inside of Ethereum mainnet. What this means is that the network developers actually gave you a way to pass messages between Ethereum and Starknet and vice versa. So you can call a function in an Ethereum contract to pass a message over to Starknet, and you can call a opcode inside of Starknet to send a message back to the Ethereum contract. And those can be consumed by contracts on both sides so that you can integrate seamlessly an Ethereum application with a Starknet application or a Starknet application with an Ethereum application. This is very, very powerful, but there's a very important concern here, which is the logic that you use. By default, no cross-chain call ever validates the sender of the messages. So you must do this inside the contract. You must validate who is sending the message over the network and handle the request depending on who is sending it. If you are meant to only send the messages for integration, you probably have to hard code the address of the other contract into the chain so that you only accept messages from this address. But if you're allowing more complex integrations, you actually have to handle how those work and how other messages are sent back with parameters of destination and what to do with the message once it passes. What do I mean by that? Let's say any contract can call a function inside the first Starknet contract from Ethereum. And then your Starknet contract gives something back to Ethereum. This message that it gives back must specify who sent the initial message. Otherwise, it's not going to be possible for the Ethereum contract to distinguish between them. What this means essentially is that this communication is stateless. When it happens, it's not like a blockchain call when you can see who sent the message before and you can act on top of it. You actually have to implement this logic on the payload here. So you have to be careful and implement it manually. You cannot just pass messages as if it were simple normal transactions. They are more complex because they have to specify everything manually. So take care with those cross-contract calls, cross-chain calls. They're very powerful, but they can be a source of vulnerabilities too. And finally, another important point in Starknet is the way that the programming works. And the truth is that it's very similar to Ethereum. The current implementation relies on serial processing, and it uses the same premises as Ethereum. So all the vulnerabilities that are used in Ethereum are valid here as well. So if you think about reentrancy, if you think about malicious oracles, if you think about anything that you're used to worrying about in Ethereum, you should worry about it in Starknet as well. This is familiar to most people, but if you are starting out on Starknet and have never programmed in Ethereum before, get familiar with the main Ethereum vulnerabilities and get to know them because they're going to be relevant in the Starknet context as well.